So this leads us into another type of function called a quadratic function. So the data in example 1 can be modeled with a linear function, which we spent a lot of time with in the last unit. Okay, so these we had f of x equals mx plus b, or we've been kind of writing them as b plus mx, kind of that starting value and then the rate at which it increases or decreases. We saw many examples in the last few chapters where data were collected for two quantitative variables and they were linearly related. Okay, so we had constant changes in both variables. But in this chapter, we're going to get another common relationship between two quantitative variables, which is demonstrated in example 2. Okay, the data in example 2 can be modeled with a new function called a quadratic function. So a quadratic function is a function whose equation can be put in the form f of x equals ax squared plus bx plus c. Okay. So this part is linear. Okay, there's our x term and our constant that we saw in the last unit. But now we've got a new term that is in place, which is ax squared. Okay, so the coefficient on x squared can't be 0. So to be quadratic, it has to have an x squared term. Okay, so we can write here b can be 0 and c can be 0. Okay, so we don't need to have, so we could have like f of x equals 2x squared. It would be perfectly fine. Okay, because we've got, we have to have the x squared terms. Okay, the x terms and constant terms are optional whether they're there or not. So in example 3, we're asked which of the following are quadratic functions. Okay, well the first one looks an awful lot like a quadratic function. We've got an x squared term, which a quadratic has to have, and then we've got some x terms and constant terms, which are okay for it to have. Okay, but the problem here is that we don't have this equal to y, some other variable, or f of x. This is just an expression. Okay, so this is an expression. And actually we could call it's a quadratic expression. But it's not a quadratic function the way that it's written. Here we've got f of x, so we have our function notation. Over here we have our needed x squared term, and then we can have some x terms and constant terms. We happen to have another constant term here, which is okay. Okay, so this one is in the right form to be a quadratic function. And this one looks similar to a quadratic function. Again, we have our needed x squared term that has to be in there. And then we can have some optional x terms and constant terms. Okay, so this is a constant term, which is okay. The problem here is that the exponent on x is not a 1, but a 1.2. Okay, so it needs to be, x to the first power for this to be a quadratic function. So in here is which of the following are quadratic functions. This one's not, this one is, this one was not. All right, so now we're asked to compute or evaluate this function for particular inputs. So earlier in this course, I've tried to get you in the habit of putting parentheses around each of the individual variables before you make any substitutions. Now in the last section, when they were linear functions, if you didn't do that, you still got a right answer. Okay, but in this section, as we're starting looking at squared terms, especially when we're going to substitute a negative value, without those parentheses, you're not going to get a correct answer. So again, it's a really good habit to get into that as soon as, before you substitute, that you always put parentheses around each of the individual variables. And notice in this term here that the parentheses went around just the x. I did not put them around this negative that was in front, but just the x. Okay. So now if we go to compute f of negative 3, so we want to know the output when the input is negative 3. So we're just going to rewrite this, and inside the parentheses we're going to put a negative 3. Okay. So now if we do order of operations, we are going to do this exponent first. So we're going to take negative 3 times negative 3, which is going to give us a positive 9. Here we're going to get 2 times negative 3. And then here we've got the opposite of 9, which is negative 9, minus 6 minus 1. So here we're going to get a negative 16. So for an input of -3, we get an output of -16. Okay, so putting those together, it means that the ordered pair -3, -16 is on the graph of f. And if we compute f of 2, again, we've got the opposite, and in here we've got 2 squared plus 2 times 2 minus 1. So again, 2 squared, we're going to get 4. 2 times 2, we're going to get 4 minus 1. Opposite of 4 is -4 plus 4 minus 1. And so here we're going to get minus 1, -1. So again, an input of 2 gives us an output of -1. So that tells us this ordered pair is on the graph of f. So again, when evaluating these functions, especially when they have square terms, very good habit to put parentheses around each of the individual variables before we substitute. All right, so example 5, we're given the function f of x equals x squared. Okay, so this is basically our simplest quadratic function. It has the required x squared term, no x terms, no constant terms, which is okay, and the simplest coefficient we can get here, which is 1, okay, since it's not allowed to be 0. Okay, so it says to explain why this is a quadratic function. So a quadratic function needs to be of the form ax squared plus bx plus c, where a is not 0. Okay. Well, the function we have can be written as 1x squared plus 0x plus 0. Okay, so a is 1, okay, which is not 0, because a can't be 0. And then the coefficient on x is 0, which is okay, and our constant term is 0, which is okay. Okay, so it fits the right form. So now we're asked to graph the following function by starting with an input-output table. So again, f of x equals, we're going to put parentheses around just the variable and square it. So this very first number, I would like you on your calculator to do two things. Okay, so one, I want you to type negative, and then the 3, and then your squared key. So if we hit -3 and square it and hit enter, okay, on your output screen you will see -9, okay, which is the correct answer for how you typed it, but is the incorrect answer to be put in this spot. Because again, before we substitute, we need those parentheses. So instead on the calculator, if we push parentheses and then do the same key punches, -3 x squared, parentheses, and enter, we'll see that we actually get the right answer, which is 9. So -2 times -2, we get 4. -1 times -1, we get 1. 0 times 0, we get 0. 1 times 1, we get 1. 2 times 2, we get 4. And 3 times 3, we get 9. So now, if we graph these ordered pairs, we get a point at -3, 9. We get another point at -2, 4. And another point at -1, 1. And another one at 0, 0. 1, -1. Sorry about that. So now, our next one, we've got our point is at 2, 4. And another point at 3 and 9. So again, we can see we don't get something that's linear, and if we try to connect these dots kind of with a smooth curve, we get something that we're going to give a name to in a second called a parabola. Okay, so we should notice that this graph passes the vertical line test. And up here, each input has exactly one output, which also tells us that it's a function.